All right, for the purposes of this practice, we have 12 integrals, and all we want you to do is determine which method of integration you would need to use. So let's go through these one by one, and of course, feel free to try these on your own and come back here just to check your answers. The first one is a factored denominator with linear factors, so you will be able to use partial fraction decomposition. The second one has the same degree in the numerator and denominator, so you will need to integrate by using long division first to simplify the expression and then integrate from there. This next one has an x squared plus 1 in the denominator, which leads me to believe it's possibly arctan. However, with the derivative of an x up here, I actually realize this is going to be u substitution with the u value of x squared plus 1 du of 2x dx. And what I would have to do to match it to this 3 is multiply both sides of the equation by 3/2. And what's going to end up happening is when I integrate this, it will go to a natural log. Okay, so don't believe that every time you see an x squared plus 1 in the denominator, it has to be arctan, because this 3x in the numerator undoes that. Next, you have x squared minus 9 in the denominator. So this one is factorable into linear factors. So we are going to be able to use partial fraction decomposition. And then this next one, we cannot factor the denominator because it's sum of squares, but the derivative of x squared plus 9 is not seen in the numerator. So this one will be arctan. So you're going to use integration using inverse trig functions here to make this go to some version of arctan. This next one, I am not seeing this being factorable, so I cannot use partial fraction decomposition, but I have an x squared that's positive and no square root down here, so I think I can get it to arctan as long as I complete the square first and then use integration of inverse trig functions. Next, looking at this one, I see that the inside function here is the square root of x, and the derivative of that will be 1 over 2 rad x. So since I see an inside function and its derivative, I realize I can just use u substitution. This next one, I see this expression in the numerator and only one term in the denominator, so I could split this into 3 fractions and then just integrate using the reverse of the power rule. Next, I have a denominator that has the square root and a negative x squared in it, so I'm going to have to factor out the 49 and use some u sub, but this is going to go to arcsine, and so I will integrate using inverse trig functions. Next, I have an expression in the numerator and denominator with the same degree, so I'm going to have to first simplify this using long division and then integrate it. Next, I have in the denominator the square root of a negative x squared, but since this is not in the form that we need for arcsine, I'm going to have to first complete the square, and then I'm going to use inverse trig integration to get this somehow to arcsine. And then last, very similar to the third one that we did up here, I see that the derivative of x squared is in the numerator of 3x, and so I am going to use u sub, and this will eventually get to a natural log function when I integrate it.